Hello everyone, welcome to the part 2 of the series Langchain and LLMs for software testing. In part 1 of this series, we explored how to generate test cases given a business use case and some nicely engineered prompt to generate certain test cases of your liking, so that we have seen that large language models can actually generate some nice test cases for us in the style and in the format that we want, and we can also provide them with certain examples of the kind of style and format that we want the test cases to be generated in, and they were able to do so. In this part, we will try to scale that idea up to see if large language models can actually execute tests for us. To begin with, we will install the required libraries like Langchain and Hugging Face transformers, and we will import the required packages. This time we are not going to use the actual size of the model, but we are going to use a quantized or a smaller version of the bigger models. To be specific, the model that we are going to use is Star Chart Beta, which is based on another model known as Star Coder, which is well-known code generation model, and it is trained on Hugging Face's big code dataset. Uh, but the Star Chat Beta model is trained on some chat uh, based dataset to make it more chatty, that is make it behave like a chatbot. But keep in mind that it, like other chatbots, for example like chat gpt, it is not trained using rlhf. So sometimes the behavior of star chat beta can be a little less robust. So if you are going to build a production ready or a critical project, then I would suggest you to choose a model that is more suitable for production level jobs. Okay, but for the sake of this tutorial, for this article, for this video, starchat beta is more than enough that we require. And why are we using a quantized model? Because quantized models are again smaller models, and they require lesser hardware resources, and the inference time is less as compared to the actual size of model. To use the quantized model, we are going to use another library known as AutoGPTQ. Now, AutoGPTQ is a very nice library which enables you to quantize bigger models or load the quantized versions of different models and use them for your inference, and then nicely integrate with the transformers library, so you don't have to worry about if by using AutoGPTQ library would you be able to use the tricks given by the transformers library or not, because as I explained that since it is easily integrated with transformers code for the transformers library, so you are well off. You don't have to think twice about it. Using AutoGPTQ is very straightforward. You have to first download the tokenizer from the Hugging Face hub using the autotokenizer.from object, and then you use AutoGPTQ for causal LM dot from context. So what this does is that it lets you pass the model name, that is a Hugging Face repository name, or even the local model path if you have one. And you can also use device map equals to auto. What it does is that it downloads the model weights and distributes it across your devices like your CPU RAM, GPU RAM, and your hard drive, enabling you to load the model much more efficiently without maxing out your GPU. Next, we are going to provide a stopping criteria, because as you know, the models can go overboard sometimes with text generation, and they can generate some text that you don't ultimately require. So we will build a list of words which we want the model to keep a track of, so that whenever those tokens or those words comes in, we will ask the model to stop there and stop the generating of text. And how are we going to use that? We are going to build an object or a class Here we call it stop on tokens. We will inherit stopping criteria class from transformers to do that. What it does is that whenever this object is called, it goes through the list of our stop words. That is the list that we build over here, and it then tries to uh, check if the generated text from the model contains any of these words. As soon as any of these tokens comes in, it returns it true, thus signaling that we have reached the stop word, and thus now the transformers library can ask the model to stop there. Again, to use our Hugging Face model locally with Langchain, we are going to build a pipeline. So we will use the pipeline object from transformers library. We pass the action, which is the text generation for us, the model, the tokenizer, and the stopping criteria that we have prepared over here. We will also pass the amount of tokens that we want to generate after which the model would stop. This is just to make sure that we don't max out our GPU RAM. Next, we use the Hugging Face pipeline object from Langchain and pass our pipeline to it, thus giving us a local model object. Now coming to the data that we are going to use here, I am going to use a dataset from Kaggle, which is a game recommendation on Steam. It is the name of the dataset. What I am going to do is that I am going to use this one as my source data, and I am going to dump this entire data onto a SQLite database. Okay, so that is my premise. So the scenario is such that I have my source data in a CSV file, which is this particular data set, and my target data is a SQLite database. So what I'm trying to achieve here is that I am building a hypothetical ETL pipeline, saying that I am taking data from a source and dumping it onto a target, and I want to test this ETL pipeline. So my main goal is to explore if we can use Langchain and large language models to actually execute the test for this ETL pipeline for us. So this is the entire premise, and I have built a couple of scripts to take the data from this particular dataset and dump it onto a SQLite database. So let us see how our data looks like. So this is a data frame that I have built by reading the data from the SQLite database. So this is my data, and I have also read the data from the actual CSV file from my game recommendation dataset and built a second data frame out of it. So this one is my source data, and this one is my target data. Remember how we talked about the language model, using a language model to check some things on our data, that is to test the ETL pipeline. So let us see what all test scenarios we can think of that the large language model can test. So these are the couple of tests that I have come up with. You can try some more tests, but for the sake of this article, I have just shortlisted three of the tests. Now there are a couple of ways to test all these test cases. So first one is by hand, that is you fire an SQL query or use some tools like pandas and all, and then manually or visually check if your intended results match your expectation or not, and accordingly you pass or fail the test. Or else you can write some automated test scripts which can do the same thing for you, which you were doing manually. Or there is a third new way, that is, what if we can use a model or an AI agent to execute those tests for us? That is, we give the test cases to it and it decides, given some tool, what action it needs to do using those tools to make sure that if the test cases passes or fails. So, in short, an agent is a model that has access to tools, and given an user input, it just decides how to use that tool to reach to the end goal. And for our purpose, we are going to use a pandas agent, which is provided again by Langchain. Now you can build your own agent, but building an agent from scratch is not part of this tutorial. Maybe I will make another video for that. If you want to make if you want me to make videos on how to create an agent or how to use your own agents, then drop a comment in the comment section, and maybe I can make a video out of that. For our purpose, we will use the create pandas data frame agent, which is provided by Langchain, and we will pass our language model to it and all our data frames, and we will set the temperature to 0, which prevents the randomness of the text generated by our model. Then we will pass our prompt to the agent.run object, which feeds our prompt to our language model and then runs the inference through it. Now you can see our model has come up with certain actions. It has generated certain code, and the Python interpreter from Langchain executes those code, and then a final answer is displayed to us with an observation. So in short, we have successfully executed this particular test case through our language model, and we didn't have to explicitly code what to do or explicitly write in a test script. The language model did that for us, so it's kind of cool. Now let us scale it up with more number of tests. We'll pass a list of test cases to our language model using the same object create pandas data frame agent with the same steps of providing our data frame and language model and everything. What we'll do will be build a loop which will feed all the test cases one by one to our agent and then run inference to it. So as you can see, the agent executes the tests one by one. It takes the test, which are the prompts, as an input and decides on what action it needs to take, which tool it needs to use, the code that it needs to use, and then it reaches our final observation. Okay, and this is precisely what we wanted, right? It is actually kind of cool that with using minimal code we have executed test cases through a language model, right? And the beauty of this thing is in during cases when the application under test goes through some drastic change, hopefully this language model can decide on the new action it has to take, the new code it has to generate, and then it would uh, uh, you know execute the test for you. Now this idea is precisely what I would like to call as self-healing test, that is test scripts which can heal themselves or mend themselves during instances of unintended test failures. And this idea was the very basis of this particular article and the in part 1 of this series. And now there were some earlier research for self-healing test, but it has never been this easy before the advent of large language models. Now my idea behind making this article was to provide a blueprint which can then be used to create framework of sorts to maybe build a system or an agent that can take your test cases as input and then execute those for you, and also repair themselves whenever an unintended failure occurs due to any breaking change in the application under test. Now this same idea can be extended over to even, I would say, web UI testing. So I would suggest you to try that out and see if it works for you. So this is all for this video. Kindly like and subscribe to my channel so that I know that the articles or the videos that I publish is useful to you, and it makes it easier for others to discover my channel as well, my content. So this is all for today, and we'll meet in next video. Thank you.